Hello guys, so we are going to continue the discussion with respect to linear algebra. Already we have started the topic with respect to matrices. In this video we are going to discuss about different matrices operations. Now understand one thing, matrix operation are very fundamental to data science because they actually provide you mechanism to probably manipulate. Let me go ahead and write this down again. So they basically provide the mechanism to manipulate and analyze multi-dimensional data efficiently. Okay. Now, already in our previous video, I've seen, right, whenever we have a data set with respect to columns and with respect to rows, we can basically take that entire information and we can convert that into a matrix, right? So considering this, the main operations in matrix that we specifically do, one is something called as matrix addition and subtraction. Second, we specifically do something called as scalar matrix multiplication. And third are nothing but the third technique that third type that we specifically will be looking at is nothing but matrix multiplication. So let's do one thing. Let's go ahead with each and every topic and let's explore this with examples and how you can probably use matrices for specific operations. So first one that we are going to understand is nothing but it is called as matrix addition and subtraction. Okay. So in this addition and subtraction, okay, it is very simple, right? Probably the most simplest technique with respect to this kind of operation. So here what we do is that we add or subtract corresponding elements of two matrices of the same dimensions. Okay. So in order to perform any addition or subtraction, the first condition is that you really need to have both the matrices or any number of matrices that you are probably performing this particular operation. It needs to be of the same dimension. So let's consider that I have an A matrix. Okay. This A matrix has data. Let's consider that we are just going to consider some data. This data is like 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Similarly, I have my another matrix which is B, and let's consider here also I have some data like 4, 5, 6, 7, 8, 9, 1, 2, 3. Now over here, first of all, we'll check whether we'll be able to perform addition or subtraction in this, right? So first of all, we'll see whether this matrix is of same dimension. So here we can see it is a 3 cross 3 matrix. That basically means 3 rows and 3 columns. Similarly, this is 3 cross 3 matrix, which is nothing but 3 rows and 3 columns. Now what I can do is that I can probably perform any kind of operation A plus B, right? Let's consider that I have this particular data set, and this data set represents daily sales. Let's say over here I'll just consider a data set of A, right? So in this data set, let's say I have features like product A, product B, and product C. Okay. And on the row wise, this is my day 1 sale, this is my day 2 sale, and this is my day 3 sale. So if I probably go ahead and write this information, it is just like 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have taken just this data set and we have converted this into matrix, right? This product A on day 1 was sold. One product was basically sold. What about product B? Here you can see it was like 2 products were basically sold. Then 3 products were basically sold with respect to product C. Now this can be the data for store A. Okay, this can be the data for store A. Let's consider that I have another store over here which is called as store A, and this can be a data of store B. At the end of the day, I really need to probably do the summation of all these stores specifically with respect to the product, right? So over here, when I do this particular addition, so 1 plus 4 is nothing but 5. So I will go ahead and write 1 plus 4. Then we'll go with this element 2 plus 5. Then we'll have this 3 plus 6. Then we have 4 plus 7. Then we have 5 plus 8. Then we have 6 plus 9, right? Similarly, here you have 7 plus 1. Then you have 8 plus 2. Then you have 9 plus 3. Okay. So if you probably go ahead and see this particular answer. So here, if I just go ahead and calculate the answer, it is nothing but 5, 7, 9, 11, 13, 15, 8, 10, 12, right? So this is my final product, right? And similarly, you can also do the subtraction if you really want. But here, I've just shown you an idea about how a specific matrix addition or subtraction can be done, okay? So the fundamental, the mechanism is very simple. We just keep on adding the corresponding elements of the two matrices of the same dimension, right? So if I have one more matrix, then I can also perform the similar operation with respect to that, okay? Now coming to the second type over here, which we are specifically going to discuss, which is called as matrix addition. Matrix addition is done. So now we are going to focus on matrix scalar multiplication, okay? So here, the second technique that we are basically going to see is nothing but scalar multiplication. Okay, now let's go ahead and check this out. So guys, now let's go ahead and discuss about scalar multiplication. Now what does scalar multiplication basically mean? So scalar multiplication involves multiplying every element of a matrix, by a scalar value. Okay, so if I consider, hey, B is my final matrix and C is my scalar, and let's say if I want to probably multiply with A matrix, right, I can basically use this. Okay, let's take a very simple example in order to understand about scalar multiplication. Okay, let's say that I will give an example over here. Suppose we have a matrix representing product prices, okay, in dollars, and we want to adjust these prices for inflation by a factor of 1.05. Okay, now if I have this kind of scenario, suppose we have a matrix representing product prices in dollars and we want to adjust this inflation by the prices for inflation by a factor of 1.05. So let's consider that the original prices, right, of all these products, let's say we have it over here, right? So let's consider this 10, 20, 30, right? Then you have 15, 25, 35, right? Then you have 20, 30, 40, right? Now, if the inflation factor is 1.05, right? Then if I want to adjust it, I will probably perform something called as scalar multiplication. Now in this scalar multiplication, what I'm actually going to do, I'll just go ahead and write P adjusted is equal to 1.045 multiplied by P, right? So it is nothing but 1.045 multiplied by 10, 20, 30, 15, 25, 35, right? And then we have 20, 30 and 40. Okay, Now, once we do this specific multiplication, you can go ahead and calculate it. That basically means scalar multiplication is this value will be multiplied to every number, right? So I will be getting 10.5, 21, 31.5. Then you have 15.75. Then you have 26.25. Then you have 36.75. Then you have 21, 31.5, and finally you have 42. So this will basically be my final vector. And this is how we basically make sure that we adjust these prices based on inflation. Okay. One example that, we can have, right? So some of the data sets, let's say, I'll just consider one data set over here, right? One data set. Let's say in an IT firm, okay? IT firm. Right, IT firms. So let's say there is a data set of base salary of software engineers. Okay, then you have base salary of HR professionals, right? Then you have base salary of accountants. Okay, let's say I have these three features, right? And I may have some different values over here. Right, let's consider that this is my base salary for company A, this is my base salary for company B in a specific city, then this may be my base salary of company C, right? So there may be different values. Let's consider that if I'm just considering with respect to USD, let's say 45k USD is for company A with respect to software engineer, HR has 30k, base salary accountant basically has 40k. Right, this is for company A. For company B, 50k. Base salary of HR is nothing but 35k. Then this is nothing but 45k. So like this, I will be having multiple values, right? But now, let's say that right now it is 2024. And let's consider that we need to update this salary in 2025 based on inflation. Let's say the inflation factor specifically in India is somewhere around 6%. Okay. So if I want to probably adjust this salary, what I really need to do is that multiply with respect to this inflation and get the values, right? And that is what we can really do, right? So when what number I need to multiply with, if 6% is the inflation, I will go ahead and multiply with 1.06, right? That's it. And once I do this multiplication, then this entire salaries will get adjusted with respect to inflation. Now here also you can see that this is my entire matrix that I can probably consider, right? Here I have 3 columns and n number of rows, any number of rows that it can be there. Okay. So some of the examples with respect to this, and scalar multiplication also specifically we use in feature engineering for doing most of the task. Okay. Now the third type that we really need to focus on is something called as matrix multiplication, and probably knowingly, unknowingly, in most of the machine learning algorithms, in most of the deep learning algorithms, matrix multiplication is extensively used. Okay. Now, what exactly is matrix multiplication? How it is basically performed? We will discuss this step by step. So first of all, we will discuss with respect to the operations. Okay. What is matrix multiplication operation? So it involves the dot product of rows of the first matrix okay, with columns of the second matrix. Okay, second matrix. So if I consider and there is one very important condition over here. If for two matrices A, M cross N, and B, M cross N is the dimension for A, right? And B, here I'm going to write the dimension as N cross P. Then if I multiply this two matrix, the result is a matrix C. C will be the resultant, and here the dimension will be M cross P. Now here you can see M cross N, when we are doing a dot operation with B matrix, N cross P, you'll be able to see this N should be always common, right? Now what is this N? n in A matrix is nothing but the number of columns. In B, n is nothing but the number of rows, right? So if these two are common, then only we'll be able to perform a matrix multiplication. And finally, you'll be able to get a new dimension, which is called as M cross P, where M will be your rows and P will basically be your columns. Okay. So just keep a thought with respect to that. Now I will just go ahead and showcase some amazing examples, and just to give you an idea, I hope everybody remembers how we specifically perform vector matrix multiplication, right? Vector multiplication. In the case of vector multiplication, I told you, right? If I have a matrix of 1, 2, 3, right? And let's say if I have another matrix, which is like, or I can also go ahead and write like this. Let's say that I have one vector, which is like 1, 2, 3. And here I will make a transpose of my another vector, which is nothing but 2, 3, 4. Now in this scenario, when we do the matrix multiplication, what exactly we are doing? We will take this element, we will multiply with the first value in the column, right? So it is nothing but 1 multiplied by 2 plus 2 multiplied by 3 plus 3 multiplied by 4. And here finally you'll be able to see that we will get a value over here. So if I go ahead and multiply this, and if I see this, 1 multiplied by 2 is 2, 2 plus 6 plus 12, right? So this is nothing but 20. So here we are able to get this specific value, and we also understood what exactly multiplication basically means with respect to two vectors. But when I say with respect to matrices, that basically means I will definitely have many number of rows and columns. So let's take this as an example. Okay, let's consider that I have something like my x-axis over here, and similarly what I will do is that, or let me just go ahead and create my two matrices. Okay, the first matrix A is basically given by 1, 2, 3, and then I have 4, 5, 6, right? And let's consider that my B matrix is nothing but 7, 9, 11, and then I have 8, 10, 12. Okay. Now, first of all, we'll see whether this matrix multiplication, is it possible to multiply these two matrices or not. Okay. So here you'll be able to see that if I go ahead and just see this matrix, it is nothing but 2 cross 3, right? 2 rows and 3 columns. So this 2 rows and 3 columns. Okay. Similarly, if I go ahead and consider for B matrix, over here you'll be able to see I have 2 rows and 3 columns. Now the condition with respect to matrix multiplication, let's say if this is M cross N, this should be N cross P, right? When the number of the number of columns at least should match the number of rows, right? But right now it is not in that scenario, right? And obviously this is not holding true. So definitely we cannot go ahead and multiply it. But now I need to perform some matrix multiplication over here. So what we can basically do in this scenario, let me just go ahead and make this as B transpose. When we say B transpose, that basically means we will just change the order of these elements. Now, before it was 7, 9, 11, right? So it was horizontal. Now we'll make it as vertical, 7, 9, 11. Now, similarly, we'll go ahead and write 8, 10, 12. Now, in this scenario, my new matrix that is probably formed, right? It is with the shape of 3 cross 2. Now, do you see this condition is basically satisfied? M cross N is nothing but, and we are trying to multiply with the another matrix, which is N cross P, right? So this number of columns is matching with respect to number of rows. My final outcome should be nothing but 2 cross 2 matrix. Okay. And then we will try to see whether we are actually able to get 2 cross 2 matrix, right? And as I said, if I really want to perform, or if I want to calculate C, it is nothing but dot operation. Now, when I say dot operation, so here I have my A matrix like 1, 2, 3. Here I have 4, 5, 6. And here I have 7, 8, 9, 10, 11, 12. Now, how do I perform this particular matrix multiplication? Let's see this. Okay. So in the first instance, as I said, here we are going to get 4 output, right? 2 cross 2, 2 cross 2. Let me just go ahead and define it. C11, C12, C13, C14. Sorry, this should be C21 because it is in the second row, and C22. Okay. Now let's go ahead and calculate everything, right? So first of all, we'll go ahead and calculate C11. Now in the case of C11, it is nothing but we have to take the first row and multiply and add it with the first column, right? So here what we'll do, we will go ahead and write 1 multiplied by 7, okay, plus, then we'll go with the next element 2 multiplied by 9 plus 3 multiplied by 11, okay. So this is my first value that I'm getting for C11. So once I do this calculation, it is nothing but 7 plus 18 plus 33, which is nothing but 58, okay. Then similarly, I will go ahead and calculate for C12. Now in the case of C12, what I'll do, I will take the first row and multiply and add it with the, first of all, I'll multiply with this element and do the summation for the second column. So here you'll be able to see, I will go ahead and write 1 multiplied by 8, 2 multiplied by 10, and 3 multiplied by 12. So here you'll be able to see 8, 20, 36. Okay, so if you go ahead and see, my output is 64. Okay, then I have C21. In C21, I will take my second row, now multiply with my first column, right? So now I will be having 4 multiplied by 7 plus, let's go to the second element, 5 multiplied by 9 plus 6 multiplied by 11, right? So once I specifically do this calculation, I will be getting somewhere around 139. Okay, you can do it. And finally, C22 is nothing but we'll take second row and second column and we'll do the same operation. 4 multiplied by 8 plus 5 multiplied by 10 plus 6 multiplied by 12 is equal to nothing but 154. So the final output that you'll be seeing, the C11 is nothing but 58. C12 is nothing but 64. C21 is nothing but 139 and C22 is nothing but 154. So this is my final output. Okay. And just trust me guys, this kind of operations, when you're seeing different machine learning algorithm and we're training deep learning neural networks, everywhere this will be specifically used and it will be extensively used, you know, because understand in deep learning, also in neural networks, we use multiple weights, right? So there also you'll be able to see. So two amazing topics that we have also learned. We have learned about transpose. What exactly is transpose and why we are specifically doing it, right? Transpose of a matrix, right? And vice versa is also fine, right? You can also transpose this and then you can multiply with this. Okay, it is up to you. So guys, I hope you like this particular video. So in this video, we've discussed about most of the matrix operations, but there are still some more topics that we really need to discuss and that we will be discussing in the upcoming videos. So yes, this was it from my side. I will see you all in the next video. Thank you.